So what we're going to be working through now is we're going to be working through the next big topic, or the last big topic in permutations and combinations, which is combinations. So up to this point, we've been doing permutations. So we did the fundamental counting principle, and then we did the formula for permutations, and now I'm going to introduce our combinations. Students initially struggle with combinations because now you have the task of every single problem I give you. Is it a perm? Does order matter? Or is it a com? Order doesn't matter. Okay? You will, when we go through these examples, you might be like, well, why is this a combination versus why was that a permutation? But after a while, you're going to see these certain words that will always make, you'll always be able to identify it being combination. And then there's certain problems. Like if you see this type of problem, it is a combination. So for example, we're going to be doing card problems, like a deck of cards. It's always going to be a combination problem. So when I give you like a deck of card questions on a test, you're not even going to think about this. Does the order matter? It is going to be a combination. Okay? And the reason why a deck of cards would be a combination, you guys, is I don't know those of you who play poker, but there's going to be a whole bunch of poker questions. So poker is like a 5-card game. You draw 5 cards from a deck, and you hold your cards in your hand, and it's called a 5-card poker hand. Those 5 cards don't matter if you like switch them up in your hand. Like you're holding 5 cards. It does not matter what order you hold those 5 cards in. Does everybody sort of agree? That's why cards are a combination. Because I give you 5 cards, and then once they're in your hand, it doesn't matter what order they're in. Okay, so let's look at this first problem. So to talk about combinations. As part of a grade 12 English course, students are required to read the following 3 books in a 3-month period. So you have to read The Grapes of Wrath. You have to read The Wars. I don't know what this last one is. The Bean Trees. You gotta read that. You actually Google it. Let me know. So you've got to read those 3 books, and in 3 months. So it says, A says, due to previous late returns, so Steve returns books late to the library is only letting him sign out 1 English book from the school library per month. Okay? List all the different orders in which Steve could sign out his books. So he has 3 different books that he has to read. So he's got 3 different books, and that would be like 3 different stages. In the first month, he gets to go sign out a book, and the teacher didn't specify which book has to be read first. So how many different choices does he have for this first month? 3. So he's got 3 different choices for this first month. In the second month, when he goes back, he would only have 2 choices of books left that he has left to read. And then in the last month, he's only got his last book to read. So there are 6 different orders that he could sign out books, right? He could do GWB. He could do GBW, right? Switch these 2. He could start with the wars, and then he could do, so there's 6 different ways that you could arrange these 2 different letters. So 6 different ways to sign out 3 books. If you could set up a problem as a fundamental counting principle, this problem is a permutation. We cannot do the fundamental counting principle or stages with combinations. We don't do this at all for combinations. So this problem, if I gave it to you, you know, this is how like 90% of you would set this up, and you're going to get 6 as your answer. Or The 10% of you would literally be doing this on a test. You'd be saying, okay, he could take out G, W, B, and then some of you would switch this and say G, B, W, and then some of you would say, okay, I'm going to start with the wars, GB, or the wars, BG, and then what's the last one he could start with? The B book. So some of you would do this. He could sign this one out first and then do Greats of Wrath and then the Wars, or B, W, G. Those are the 6 different ways, right? So there's 2 different sort of methods that you could do. I never recommend doing this method. I always recommend doing this method. But that would be what we call a permutation. The other way we could have done this is just off to the side. 3 factorial is 3 times 2 times 1, which is 6. Then we get to B. We got a different student, Tariq. He is allowed to sign out all 3 books at the same time. So he hands his books in on time. So he can go to the library and they'll let him sign out all 3 books if he wants. How many different ways is there to sign out 3 books at once? Kind of sounds like a weird question. But if he needs to get 3 books, and he says, I need these 3 books. Do you guys know how many different ways there are to sign out 3 books? There's only one way, right? He goes and he says, I need these 3 books. It doesn't matter which one the librarian hands him first. Do you guys agree? Like, so when he goes to the library, he says, I need these 3 books. There's only one way to sign out 3 books, even though they're different books. He's got all 3 books, right? So there's only one way to sign out all 3 books. So for Tariq, the order does not matter. It doesn't matter if she checks out, if she scans in the Greats of Wrath first. Like, it doesn't matter what she scans in first. He gets to leave with all 3 books. Whereas this guy, the order matters. So Steve's problem would be a permutation. Tariq's problem would be a combination. So when we see the word selection, so if you were asked to select, that is going to be a combination. So how many different ways can we select something? It's going to be a combination. If you remember, see the word arrange, it's going to be a permutation. When you watch the videos, and she's going to talk about like her favorite example for a combination, then I'll tell you another one that I always will tell students to remember. So for combination, so what are some examples where order does not matter? So like signing out 3 books from the library, right? If you just need 3 books, it doesn't matter which way she scans them in. In my friend's videos, you make a fruit salad. That would be an example of a combination problem. Because if you're making a fruit salad with apples, bananas, grapes, and 4th fruit, does it matter what you throw in the bowl first? Doesn't matter, right? Another one would be like condiments on your hot dog. So condiments. You go to Harvey's and they say, what do you want on your hamburger? And you say, like, I want ketchup and mustard. Doesn't matter if they like grab the ketchup bottle first, or you go, like, mustard's got to go first, right? So that would be a ketchup and mustard, or mustard and ketchup. It doesn't matter. It doesn't change anything. That would be a combination problem. So permutations. So this little guy here. Permutations are going to be arrangements, and order matters. Combinations are selections, and order does not matter. So let's write for permutation. We always have to remember that order matters. And like I said, I will specifically give you other examples that we're going to do in class. What makes this a com? What makes this a com? Combination, order does not matter. Okay, flip your page. And let's do one more problem. So the first one was the books problem, one was a permutation, one was a combination. Now we're going to do a race. Okay. So 5 students, Al, Brian, Colin, Dave, and Eric, take part in a race. So Al, Brian, Colin, Dave, Eric take part in a race. Suppose, okay, when you have a race, you got a first place, a second place, and a third place. So the winner's going to get $50, the runner-up, which is second place, gets $25, third place gets $10. How many different ways can these 5 kids that I sent to a race get first, second, and third? So you would say, okay, you're running a race. A race has a first place, has a second place, has a third place. If we were doing this question, you would say, if you're running a race, 5 students have the possibility to get first, right? But once the first guy crosses the line, there's 4 people left that vie for the spot of second, followed by third. The way I've set it up, is this a permutation or combination? Because I set it up using the fundamental counting principle. What would this be? Permutation, right? So 5 times 4 times 3 is equal to 60 ways that those 5 kids could get first, second, and third place. The reason why order matters when you run a race is, let's say that Brian got first, let's say that Eric got second, and let's say that Al got third. The order matters because I can't take Brian and say, you know what, Brian, you did win in the top 3, but I'm just going to write you down here, right? Because then I just gave him third place. So in a race, the order matters, right? It matters who gets first, because if I say, like, okay, you guys, these are the 3 that won, B, E, and A. Can I write it as like A, E, B? No, because then if I write it like that, then all of a sudden I'm saying Al got first, right? So the order matters. Like, this would be an example of order matters. Now, how I could change this to where order doesn't matter, like how could I do a race question where order doesn't matter, is B. So let's look at an example for B, where the order doesn't matter. Just for participating in a race, okay, what does it say? For participating in a cross-country race, the school has been awarded 3 places at a running clinic. The school coach decides to select 3 lucky students from the 5 who took place in a race. Okay, so this is an example where order doesn't matter. So let's write order doesn't matter. So order doesn't matter. Let's box in the word select. When we select, it's going to be a combination problem. So here's what we had. I've got 5 kids in my class, A, B, C, D, and E. From these 5 kids, I'm just going to select 3 of you to like leave my class. If I select 3 of you to leave my class, it doesn't matter which of you leaves my class first. Do you agree? Like, these 3 have to leave. It doesn't matter if Kyle walks out first, then Renee, then Angel, or they're just leaving my class. The order does not matter. I'm not giving Kyle first place for leaving the room first, right? So if you're just selecting 3 of you to leave, that is going to be a combination problem. How you would write this, I'm going to select 3 of these kids to leave my room. Then here's how you would write it. There's 5 students. I am going to choose 3 of them to leave, and it doesn't matter which order they leave in, it becomes a combination problem. You read this as 5 choose 3. Up here, this one was 5 permute 3. 5 permute 3 gave you 60 possibilities. Can you guys type in on your calculators 5 choose 3? When order doesn't matter, you have a lot less combinations. So what is 5 choose 3? 10. Yeah. So if I had 5 kids here, and I said 3 you gotta leave my room. I only have 5 kids in my class, 3 you gotta go. It doesn't matter which 3 go, like what order they leave in, just 3 are leaving. That's a combination, and there's only 10 ways that I could select. Okay. Okay, let's do class example 1 and 2. So class example 1 says 3 students from a class of 10. I've got 10 of you in my class, and 3 of you get to be chosen to go on a trip. It doesn't matter the order that I choose the 3 in. It does not matter, right? So let's say like in this class here, like these 3 kids get chosen to go on a trip. It doesn't matter if I pick Angel first, then Renee, then Kyle, right? Like that doesn't matter. It's these 3 are chosen. So order does not matter. Oh, before we actually start this, star this. This is your formula for combination. I'm teaching. Yeah. Okay, bye. Okay, so this is your formula for a combination. It is identical to a permutation with the exception of a permutation. This was the formula for a permutation. So a combination, they just tack on an r factorial in the denominator, and you will be given this on your formula sheet. Okay? So let's do this first one, and they want us to use the formula. So 3 students from a class of 10 are chosen to go on a school trip. It doesn't matter the order that I choose the 3 in. In how many ways can they be selected? Write the answer in factorial notation and evaluate. So n, remember, is the total number of students, and r would be how many I'm selecting. So total number and how many I'm selecting. So there's 10 total students in my class, and I'm choosing or selecting, what did it say, 3 of them. So that would be n factorial, which is 10 factorial, all over n minus r. So that would be open bracket 10 minus 3, close that bracket, put a factorial, and then r is 3 factorial. So that would be 10 factorial all over 10 minus 3 is 7 factorial times 3 factorial. Unzip 10 factorial. So 10, 9, 8, 7 factorial all over 7 factorial times 3 factorial. 7 and 7 would cancel. And then you would type in on your calculator 10 times 9 times 8, hit enter, and divide that by 6. 3 factorial is 6. And what you should get is there's 120 different ways. 120 different ways. If I have 10 kids in my class, to choose 3 of them to go on a school trip, there's 120 different ways. Confirm the answer using and choose R on your calculator. So just confirm for me on your calculators, type in 10, choose 3, and you should get 120. Okay, let's do class example 2, which is the lotto 649. So I'm going to tell you, you should go home tonight and ask your parents, because I bet most of them play the lottery, and ask them, because you're going to know the answer after this question, what are your chances of winning the lotto? 1 in how many chances? Okay, so after we do this question, you're gonna know this. Just to quickly explain to you guys how to play the lottery, because you shouldn't have played, because you gotta be 18 to play. It's called 649, and it's actually a clever way to do this. So just write actually 6-49. So how the lotto works is there are 49 numbers to choose from. So the numbers 1 to 49, so that's where the 49 come from. How many do you think you choose? Do you guys know how many? Yeah. So from the numbers 1 to 49, you pick your favorite 6 numbers. And then if those 6 numbers get drawn from the 49 numbers, you win the lotto. The reason why the lotto is a combination problem and not a permutation is because let's say these were your lucky numbers, 3, 7, 9, 11, 20, 29. So you buy a ticket and these are your lotto numbers. If they draw a 21st, do you guys think they have to draw it in this order? Do they have to draw the 3, then the 7, then the 9 to win? Or could the person like drawing, say they draw the 11 first, and then they draw the 3, and then they draw the 29, and then they draw the 7. As long as they draw, it doesn't matter what order they draw them in, if that's the winning combination, you win. Okay, so that's how it goes. So order for the lotto does not matter, because if they draw the 29 first, doesn't matter. As long as you have a 29, you're good to go. And then the next number they draw is a 9. Ooh, look at that, I got 2 numbers on the lotto. Right, now you're gonna wait, what's the third number they draw? It doesn't have to be order. So the lotto is a combination problem. Okay, how many numbers are there to choose from? You guys, how many numbers on the lotto? 49. How many did you get to choose? 6. So if you type in, so type this on your calculator, 49, choose 6. This is how many different combinations there are in the lotto 649. So the number that should be spilling out is 13,983,816. So let's just round this so you can remember this to tell your parents. You have a 1 in 14 million chance of winning the lotto, is what you have. So just sort of an interesting aside, let's say you're a millionaire, like you got tons of money, right? So 1 in 14 million. Let's say the lotto was a $15 million draw, okay? It's $1 for a ticket. You could theoretically spend $14 million by every single combination, right? How much would you win? How much would you profit? If you spent $14 million on the lottery, you know if you buy every single combination, you're gonna win the lotto. How much would you profit if it was a $15 million lotto? $1 million, right? Does anybody know what the issue with doing that though? Other than it's gonna take like you a year to buy every single combination of tickets. The issue is 2 people could win the lotto, right? So this might be your lucky numbers, but this might be Cyriel's lucky numbers as well, right? So if somebody did that and they spent $14 million because they knew that they were going to win, right? And 2 people won the lottery, they just lost. They've got to split this 50 million, right? 2 people win the lottery, this person gets 7.5 and this person gets 7.5, right? So yeah, 1 in 14 million. So there used to be the saying, well, there is a saying, that people who play the lotto are bad at math, right? Because you've got like 1 in 14 million chances, but people play the lotto because there's still a chance, right? So even though it's 1 in 14 million. Okay, let's do class example number 3. The athletic council decides to form a subcommittee. So a couple things I want you to box in. Box in or highlight subcommittee. And whenever you see the word committee, whenever we make a committee, committee starts with C, and combination. Starts with C. Okay, so forming a subcommittee is going to be a combination problem. So here's like an example of what a subcommittee is. You guys know how there's like a grad council? So in our school, there's a grad council. So people were selected to be on the grad council. Now, when we're selecting like a president, a vice president, and a secretary, order matters. That's going to be a permutation. But let's say that there's 20 kids on grad council, and I have to make a subcommittee of 5 kids to like hand out flyers. As soon as I make a subcommittee, it doesn't matter the order of the 5 kids. It's just 5 kids from my grad council need to be selected. That would be a combination. So a subcommittee, the order doesn't matter, it's a combination. So what it says is athletic council decides to form a subcommittee. They want a subcommittee of 7 council members, and there's 15 council members total. So there's 15 council members, and they want to make a subcommittee of 7. Okay, and then it says from the original like grad committee, there's 9 males and 6 females. The subcommittee must consist of exactly 3 females. Okay, so let's box in. The subcommittee must consist of exactly 3 females. So what that means is, how many members do they want on this subcommittee in this question? 7. If they want 3 females, there must be exactly 3 females. What that means is there's going to be 3 females and how many males? If there's got to be exactly 3 females, how many males? 4. So 3 females and 4 males. Okay. So if they need a 7 council subcommittee, and they want exactly 3 females, that means 3 females and 4 males. Okay, determine the number of ways of selecting. Whenever we deal with committees, it's going to be a combination, the females. They want 3 females. How many females were there to choose from? 6. There were 6 females total, and we are choosing 3 of them because we need exactly 3 females. So if you typed in 6 choose 3 on your calculator, you're going to get 20. There's 20 ways of selecting 3 females from 6 females total. Let's figure out the number of ways of selecting the males. They need 4 guys, and they've got 9 to choose from. So that would be 9 choose 4, because they need 4 males on the committee. 9 to choose from. 9 choose 4 is 126. That's for selecting the females. This is how many ways of selecting the males. How many different ways are there of selecting the subcommittee? So the subcommittee is made of 3 females and 4 males. And means multiply. The number of ways of selecting 3 females. So we've already done it, but it was 6 choose 3, which was 20. And the number of ways of selecting 4 males, we've done it, was 9 choose 4, which is 126. So the total number of ways of selecting a subcommittee that consists of 3 females and 4 males is going to be those 2 numbers multiplied together, which is 2,520. Different ways. Okay, B is going to complicate this. So most students look at these 3 and they're like, oh, you know what, I get this, and I get this. Then I'm going to show you B, and after you see B, then you'll know how to always do this. If this is going to happen. How many different ways can a subcommittee be selected if Bruce, the football coach, must be included. Okay, so how we're gonna do this one is we're making a subcommittee. Bruce is on the committee, and 3 females is on the committee, because remember it said exactly 3 females, Bruce is a guy. And now, here's what we've got to change. We had 3 females and 4 males. But now they want my subcommittee, Bruce is on the committee, he's there, plus 3 females. How many males are over here now? It was 4 that I would select, but Bruce has been selected, so that means that there's 3 more males to choose from. So because Bruce has been selected, there would be 3 males over here. Okay, so the number of ways to choose Bruce is just one way. You don't even have to really do that if you want, right? If Bruce is on the committee, there's only one way to choose Bruce. And 3 females, we had that up here, which was 6 choose 3, because there was 6 total to choose from for girls, and we're choosing 3 of them. So 6 choose 3. 6 choose 3 times. Now, males, we got to be careful. We're choosing 3 of them, but how many males do I have left in my pot after Bruce is gone? Because I can't keep Bruce in the pot, right, to choose them. So how many males, like, it's not going to be 9 choose 3 for the males, because you know how I said there was 9 males total? How many males now are there if Bruce is out of the pot? There's 8. So you placing Bruce, you've got 8 guys left to choose from. So that would be 8 choose 3. And that's going to be a 9 council subcommittee. Bruce plus 3 is 4, plus 3 is 7. Okay. So 6 choose 3, we know that that number is 20. And 8 choose 3, are you guys getting 56? Okay, so it's 1 times 20 times 56. There'd be 1,120 different ways of selecting a subcommittee if Bruce is on a committee, for sure. Last class example is our deck of cards. Okay, so they love doing deck of card questions, and you're going to get deck of cards on any quiz or exam that you ever write for permutations and combinations. Card questions, remember, are always going to be combinations, because once you make a hand of cards, it doesn't matter what order the cards are in. That's why it's a combination. So what's a little bit tricky about cards is some students they're in grade 12 and they've never played a game of cards in their life. So they're like, I don't know what's in a deck of cards. So I'm going to go through what's in the characteristics of a deck of cards. But what I will do, and what the diploma always does, is if ever they give you a card question, they will tell you the characteristics that you need to know. So what happens, you guys, a deck of cards, if you opened, there would be 52 cards. There's 52 playing cards in a deck. And those 52 cards, when you open a deck of cards can be divided into 4 what's called suits. So there's clubs, spades, hearts, and diamonds. Okay, so 52 cards are divided into an equal number of clubs, spades, hearts, and diamonds. Because it's an equal number, if you divide 52 by 4, I'm not doing this in black, because clubs are black, you're going to get 13 cards that are clubs. They've got the club picture. 13 that are spades, because they have a little shovel. You're going to get 13 cards that are hearts and 13 cards that are diamonds. What that means is in your deck of cards, you're going to have 26 black cards. So half your deck is going to be black, and half your deck is going to be red. So this is how a deck of cards work. Then the other thing that you need to know about cards is, jacks, queens, and kings, they're considered face cards in a deck. So there's like a face, there's a jack that's a club, a queen that's a club, and a king that's a club. Same with spades. There's a jack spade, a queen spade, and a king spade. So if I said, how many face cards are there total in a deck of cards? If there's 3 for each suit, how many face cards are there in a deck of cards? What would it be? So there's 3 face cards for clubs, 3 here, 3 here, and 3 here. How many face cards are in a deck? 12. 3, 6, 9, 12. Ace is not a face. Okay, so an ace is generally considered like the lowest card. It's a 1, depending on what game you're playing for poker. Okay, so poker is a card game played from a deck of 52 cards. So when you play a game of poker, you play with a single deck, and you draw a 5-card poker hand if you're playing 5-card poker. How many different 5-card poker hands are possible? Okay, so for A, you've got 52 cards in a deck, and you're gonna choose 5 cards to make a 5-card poker hand. So it would be 52 cards total, and you're choosing 5 of them. So the amount of 5-card poker hands are 2,598,960. So there's almost 2.6 million different 5-card poker hands that you can make from a deck of 52 playing cards. That's what you need to get from this. Okay. In how many of the hands, so out of these 2.6 million hands, out of all of the combinations of 2.6 million hands, how many hands drawn would be all diamonds? So what you have to think of is, how many diamonds are there total? So let's look up here, you guys. How many diamonds are there in a deck of cards? 13. So there's 13 diamonds, and they're saying, what are the chances that if you have 13 diamonds in a deck, choosing 5. Because remember, you're making a 5-card hand. So 13 diamonds, and we're going to select all 5 happen to be diamonds. So that would be 1,287. So out of this 2.3 million, almost 1,300 hands could be all diamonds. Okay, how many hands in a 5-card poker hand would be 4 black cards and 1 red? So I always like to write this in words. So 4 black and 1 red. Okay, so you say to yourself, how many black cards are in a deck? You go up here, there's 26 black cards in the deck. 26, choose 4. And let's multiply 1 red. So you look at your characteristics of cards, there's 26 reds in a deck, and we're going to choose 1. So that would be 26, choose 1. If you have the older calculator, make sure that you're entering these in brackets. Your newer calculator, you don't need to, but the older you do. The number of possible hands that would have 4 black and 1 red, 388,700. Okay, how many different hands are possible that you would draw 3 kings? So 3 kings and 2 queens. So you got to figure out How many kings are in a deck? And we're going to draw 3. How many queens are in a deck? And we're going to draw 2. So Brenna, how many kings are in a deck? 4. There's 4. There's 1 of each suit. So 4 kings, choose 3, times queens. Emmanuel, how many queens are there in a deck? If there's 4 kings, 1 of each suit, how many queens would there be? 4. Yeah, there's 4 kings, there's 4 queens, there's 4 jacks, 4 tens of each. There's 1 of each suit. So there would be 4 queens, and we're choosing 2. So there would be 24 possibilities out of that 2.6 million. Okay, when you do something like this guy, so students are like, yep, I get this, I get this, I get this. I would now know how to do any of those card questions that I asked, right? That's how you do it. What if I said 3 kings? You always want to set this up as words so that you don't mess this up. So you say to yourself, okay, it's a 5-card hand, right? So 3 of the cards are going to be kings. So 3 kings. And what that means is the remaining 2 cards, because it's always in poker a 5-card hand, 2 have to be non-kings. So now I'm going to show you how to do a non-king. So you might want to star this one to put it on a study sheet. How would you do, like, if I just say 3 of something, then that means 2 of not that would be the other ones. So 3 kings, so say to yourself, how many kings are in a deck of cards? There's 4 kings, 4 choose 3. 4 choose 3. Okay, drawing a non-king. What you have to do for this one is you have to say there's 52 cards in a deck, and I'm going to take away those 4 kings. What that leaves me with is, if it's a non-king, there's 48 cards in your deck of standard playing cards that are not kings. So how many possible ways are there of drawing 2 non-kings from 48? So that would be 48 choose 2. Okay, so if it's a non-king, there's 48 cards in your deck that are non-kings. So you'd say 48 choose 2. And you would punch that in your calculator and you get 4,512. Okay, 4 aces. How many possible hands can be drawn that would have 4 aces? So writing this in words, that means 4 aces and 1 non-ace. Right? If you're drawing 4 aces, that would be 4 aces and 1 non-ace. Okay, how many aces, Haley, are in a deck of cards? Do you know? So there's like 4 kings, there's 4 queens, there's 4 nines, there's 4 eights. There'd be 4 aces. So that would be 4 choose 4. Okay. Now we got to figure out how many non-aces are in a deck. It would be the same as the non-kings. There's 52 cards in a deck. If I take out the aces, I'm taking away 4 of them. 52 minus 4 is 48. There's 48 cards in a deck that are not aces. How many can we draw 1 of those? That's not an ace. It would be times 48, choose 1. And that would be, if you multiplied 4, choose 4 times 48, choose 1, you should get 48 different hands can be made. Okay, the last one, again, these are the only combinations, you guys, that I would ask for a card game question. Okay, drawing 5 cards of the same suit. This is called a flush. So if you just randomly pick your 5 cards, you look at your 5 cards, if they're the same suit, you see 5 hearts, or you see 5 clubs, 5 spades, 5 diamonds, you just do a flush. Okay? Ooh, I got a flush. So here's what's a little bit of work about this question. Your flush could be 5 hearts. Does everybody agree? That could be your flush. If I said, well, how many different possibilities of there drawing 5 hearts? You would say, okay, there's 52, oh, no. 5 hearts. How many hearts are there in a deck? 13. So drawing 5 hearts, it would be, there's 13 hearts, choosing 5 of them. Okay. However, it might not be 5 hearts that you draw. What could it also be? Yeah, so I gotta say, oh, or your flush could be 5 diamonds. And then you'd say, well, there's 13 diamonds, choosing 5. Or, Claire, what's another thing that our flush could be? Yeah, 5 spades. So 5 spades, and you would say there's 13 spades, choosing 5 of them. Or the last possibility is your flush could be, what am I missing? Clubs, 5 clubs. And there's 13 clubs, choosing 5 of them. So you could do it in this way. And you guys know that or means what? It means add. So it's going to be this. This one I messed up. It should be a 13. It's going to be this plus this plus this plus this. The way the textbook did it, so you could do it this way. The way the textbook did it is they did 13 choose 5. And what do they multiply that number by? 4, right? Because this plus this plus this plus this is the exact same thing as whatever 13 choose 5 is, multiply that number by 4, and you should get 5,148, whether you add or whether you do it that other method. If this was an exam question though, and it's a card question, and I said, you know, drawing a same suit, or yeah, getting a flush, I would probably do this plus this or this or this or this to show that you like really understand that it could be a heart, 5 hearts, or it could be 5 diamonds, 5 spades, and 5 hearts. So those of you that are, I always tell my students, if you are not familiar with a deck of cards, like playing cards, you want to do these questions and then you do them again, basically, so that you understand that you're not thinking too much on it when it comes to your exam on Tuesday. How many black cards are there? How many red cards? How many kings are there? That you are sort of familiar with those. Here's what we want to circle. So for this homework, you want to circle number 1, number 2, and then 4 to 12. Let's do 11 together, because 11 are combining a combination of permutation. So let's do 11 together, and I would say that 11 is the most challenging for this. So just look at 11 for a second, and then I'll open it. Okay, there are 3 girls and 6 boys on a baseball team. So it's made of 3 girls and 6 boys. Each student is capable of playing any position. So what that means is like the guys and the girls are equally as capable of playing any position. They've got equal chance of getting a position. And there's 9 positions total. These are the positions. Doesn't really matter what the positions are. So it says for a particular game, okay, it says if the pitcher must be a girl and the catcher must be a boy. So the pitcher must be a girl. So how many, there's 3 girls and 6 boys. How many ways are there of choosing a pitcher if we're choosing one of the girls to be a pitcher? So there's only one position for pitcher, right? You're only picking one pitcher. Does anybody know what it would be? It's not a tough question. If I say you've got 3 girls, choose one of them to be the pitcher, like what's that going to be? 3 choose 1, right? So for the pitcher, let's write down pitcher. They want the pitcher to be a girl. There's only one pitcher position in baseball, and there was 3 girls. So out of the 3 girls, we're choosing one of them. Okay, so my team has the pitcher. And, right, so and is going to be multiply. And then it says, okay, if the pitcher must be a girl and, so here's your and, the catcher must be a boy. So in baseball, 1 kid gets chosen to pitch, 1 kid gets chosen to catch. What would the catcher be? Louise, any idea for the catcher? There's 1 catcher that we're choosing, and how many boys were there to choose from? Because it has to be a boy.
6.
Yeah, there's 6 boys. Okay, so to choose the catcher, there's 6 boys to choose from. So there's 6, choose, we're choosing 1. So this is how many combinations I'm going to get to select the girl pitcher times this many for the boy catcher. And then what it says is then it doesn't matter who gets what from there. Like those are the only 2 that matter. So for your positions, it said that there's 9 positions total. Okay, so there's 9 positions. How many did I just select to put in spots? How many kids are out of the pool now? 2. What that means is I have 7 positions left in baseball, and it doesn't matter who gets what they're saying. So there's 7 positions left. 6, 7. I would have 7 students to choose from for that position. And I got 6 here because they're not saying it's got to be a guy or girl, right? So that's where it started as a combination problem. And then for the remaining 7 positions, they're saying it doesn't matter who gets what, guys or girls. I've got 7 kids to choose to get this position. 6 kids can go here. 5, 4, 3, 2, and 1. This is a combined combinations permutations problem. The answer is 3 choose 1 times 6 choose 1 times 7 factorial. And your answer would be A. And that's how they get it, right? So if you guys were just look down here, you would be like 11A. Well, how are they getting A? This is the pitcher, this is the catcher, this is the remaining 7 kids, and it doesn't, you got 7 kids to choose for that position, 6 here, 5, 4, 3, 2, 1. But it becomes a permutation at this stage here.